All right, welcome back. Let's talk about metamorphic rocks. Now, we first have to start with a parent rock, a protolith, which is what we see over here. We apply heat, we apply pressure, and once they metamorphose, they become this rock over here. So again, if I take shale or some other type of sedimentary rock like mudstone or siltstone, fine-grained sedimentary rock, and I apply heat and pressure, it becomes slate. Slate with more heat and pressure becomes phyllite. Phyllite with more heat and pressure becomes schist. Schist, or igneous rocks like granite and other volcanic igneous rocks, crystalline, phaneritic, visible crystal igneous rocks, apply heat and pressure, and then you get something called gneiss. So this is increasing metamorphism, and they all have foliated textures. They'll have foliated textures. Now, there's actually a separate branch of metamorphic rocks that are non-foliated. There's still some existing parent rock that has undergone heat and pressure to change them, but they're not foliated. There's not layers or mineral bands. For instance, limestone as a protolith. When you apply heat and pressure, it becomes marble. Marble's a metamorphic rock. Sandstone, when you apply heat and pressure, becomes a metamorphic rock named quartzite. Quartz is a mineral. Quartzite is a metamorphic rock. And then you take a sedimentary rock like bituminous coal, apply heat and pressure, and it becomes an even higher grade of coal, in this case becoming metamorphosed, becomes a rock called anthracite. So the first thing and these are all non-foliated. They don't have layers or bands of minerals. So those make it a little bit harder to identify. So the very first thing you do when trying to identify metamorphic rocks is look at their texture. Is it foliated or is it non-foliated? And most of these rocks we will look at in lab. Besides structural changes from parent rock to new rock, mineral changes can also occur. This is a little bit more advanced, but I wanted to touch on it nonetheless. So depending on the original composition and the pressure and temperature experienced by the protolith, parent rock, there may be chemical reactions between the minerals in the solid state to produce new minerals. The heat is somehow activating the existing minerals in the existing parent rock and somehow causing them to combine and or change. When these minerals change, they often change in a metamorphic rock into something called an index mineral. Now, an index mineral is found in a metamorphic rock. It indicates the minimum pressure and temperature the protolith must have achieved in order for that mineral to form. So, some minerals that you are familiar with, we identified back in that mineral lab, things like muscovite, biotite, garnet, starlite, kyanite, quartz, things of that nature. So depending on what mineral you find in a metamorphic rock, you can then assess whether it's a low grade or high grade or somewhere in between metamorphic rock. So for instance, if we're looking at slate, might have some biotite and muscovite. Definitely not any garnet or starlite or things of that nature. But if you do, for instance, find, for example, let's say starlite, starlite, that usually exists only in schist or gneiss or something in that realm. So sometimes being able to pick out certain minerals will also help you zoom in and figure out the type of metamorphic rock you're looking at. But probably most easily what we will focus on is first, when identifying metamorphic rocks, is it foliated, bands and or layers, or is it non-foliated? We don't see those things. So that's where we'll typically start it off. So we're going to go ahead and pause there. When we come back, we'll talk about, there's different types of metamorphism. There's different methods in which we can apply heat and pressure to a rock. There's 4 different types, and that's what we'll talk about when we come back. See you in a second.